Okay, once again, good morning, friends. My name Daturaj, and today we are going to start lecture number 2 of our first chapter of PWE DC circuits. So, today we will discuss about Maxwell's mesh current method. So, I will just write it. Okay, so now I am going to write the theory of this. You may please note down. So, point number 1, in this method, KVL is applied. What is KVL? KVL is Kirchhoff voltage law. To each mesh in terms of mesh currents instead of branch currents. Now talking about second point. So what does the second point state? Number of unknown currents equals number of unknown mesh. Is equal to number of unknown mesh. Next, super mesh is made up of two mesh by opening the common branch. A common branch in which current source is present. Okay, so as you can see, I am also copying it from another book. So this is important as for the theory questions which come in the university papers. The main part of this is the application in the solving sums. So now I will just write down the sum, till then you then copy this. Okay, now I will give you a sum, a very basic level sum. my 2 ohm, this is my 3 ohm, 5 ohm, again 3 ohm, and this is my 2 ohm. This voltage source is of 3 volt supply and this is of 5 volts. So friends, as we discussed in previous lecture, we can see 3 mesh in this circuit. So I will just name them. This is mesh 1, mesh 2, and this will be my mesh 3. I will just circle it so that it will avoid confusion. Okay, now to solve this sum with the Maxwell's mesh current method, our question is current through 5 ohm is how much? This is our question. Okay, now to solve this question with Maxwell's mesh current method, we need to consider a current with a clockwise or anti-clockwise direction. So there are 3 mesh, so we will take into consideration 3 unknown currents. Okay, so I am considering it a clockwise direction. This is my I1, well, this is my I2, and this is my I3. Okay, so hope that you all have revised KVL law, which I had explained in previous lecture. Now let's solve the sum. So I will write here, apply KVL in mesh 1. Okay, so we will solve first for mesh 1. Okay, so our main core direction is clockwise and the voltage source is in direction with clockwise, so it will be plus 5. Okay, then it will be I1 minus 2 times I1. Now at 3 ohm resistance it will be minus sign, and the I1 is clockwise and I2 is anti-clockwise for 3 ohm, so I2 will have negative sign. So we will write in bracket I1 minus I2 is equal to 0. So on simplification we get the equation as minus 5 times I1 plus 3 times I2 is equal to minus 5. We will box this equation and consider this equation as equation number 1. Now apply KVL in mesh 2. Okay, so this is my mesh 2. Now it is having only 5 ohm resistance, so I will write it as minus 5 I2 is equal to 0. Okay, so answer seems to be quite direct. I will just change the question and I will also add a question, find current through 3 ohm. Okay, now this makes some more interesting. Okay, now I will write apply. I will consider this as equation number 2. Though we can directly calculate its answer, I2 is 0, then also we will consider 3 variables, 3 unknowns, and we can easily solve it on scientific calculator. Okay, so now this is apply KVL in mesh 3. So this is my mesh 3. Now in mesh 3 again our core direction is clockwise, but the voltage source seems to be opposing it, so we will have a negative sign on the voltage source. So it will be minus 3 times I3 plus again minus 2 times I3 is 0. Okay, so this is my one more equation. I will name it as equation number 3. So, okay, On solving all three equations, finally we get result as I1 is equal to 1 amp flowing in clockwise direction, I2 is equal to 0, and I3 is equal to minus 3 upon 5. Okay, so our question is I5 ohm, I2 5 ohm resistance, which will be equal to I2 and which will be equal to 1 amps flowing in clockwise direction, and current through 3 ohm is equal to I3, which is equal to minus 3 upon 5 amp. Now what does this minus sign indicate? This minus sign indicates that direction which we considered is wrong. Now in this question we considered current to be clockwise. So in reality current is flowing anti-clockwise. That's the only conclusion. If we had considered the current direction to be anti-clockwise and with the minus sign, then the current would flow in clockwise. So in this sum we will write here 3 upon 5 amps, which will flow in anti-clockwise direction. So friends, mentioning this sign with a direction, magnitude with a direction is very important in university exams. So hopes you copy this. I will rub this and move on for the next question. Okay, so moving on for the next question. Now let us have some more difficult question in which we wanna use source transformation. Okay, so I will just draw the question circuit diagram. It is like this. It is 6 amps and 3 ohm. Well, point to be noted, this is in series. Okay, next is 5 ohm. This is my 5 ohm resistance. Now next is my 6 ohm resistance. Next is I am having here 10 ohm resistance also. Next I am having a voltage source of 10 volts and one more resistance of 2 ohm. Next I have one more resistance of magnitude 4 ohm, which is in series with one more resistance 3 ohm, which is in series with a resistance of, how much was the magnitude? 6 ohm again, and it has a current source in parallel of magnitude 2 amps. Okay, so this is my question. Now what is it to be found out is current through 4 ohm is how much. Okay, so we need to specify magnitude as well as direction of current. Now in this question, as you can see, 2 amps and 6 ohm are in parallel, so we can use source transformation in this question. Here 6 amps and 3 ohm are in series, so we cannot use source transformation here. Okay, in this part no source transformation, and this part source transformation. So we will reconvert this diagram as follows. This is my 6 ampere, this is my 3 ohm resistance, 5 ohm, 6 ohm, again one more 6 ohm. Direction is in this way, 3 ohm, 10 ohm. Again my this will be 10 volts. And more resistance. Okay, so this is 3 ohm, 4 ohm. Now what will be the value of this voltage source? So according to Ohm's law, V is equal to I into R. Therefore 6 into 2, which is 12 volts. This is my 6 ohm. It has converted into a parallel combination of a resistance and a voltage source. This is my 10 ohm. Oh, I forgot to connect this. Okay, 6 ohm, 5 ohm, and this is my 3 ohm. Now what to do about this 6 amps? So we will consider that this 6 ampere is flowing along this circuit only. It is restricted in this mesh only. So this is my mesh 1. This mesh is 10 volts. This is my mesh 2 and this is my mesh 3. So again current direction I1, which is clockwise, here I2, and here I3. Okay, so I would like to again explain that 6 amps is considered to be only in mesh 1. So 6 amps will be flowing from 3 ohm resistance as well as 5 ohm. It is only restricted in mesh 1. Okay, so KVL in mesh 1. Okay, so now what will be the net current flowing through 3 ohm? So we will assign negative sign because it's in KVL law. 3 into, now the direction of 6 amps and I1 is same, so we can sum up them. I1 plus 6. Now current through 5 ohm, again negative sign outside bracket. We will write here I1 plus 6 minus I2. Direction of I2 is upwards for this 5 ohm, so it will be negative, and this entire thing is equals to 0. Okay, so now moving forward, let us write the final equation for the mesh 1. It will be minus 5 plus 3, 8 I1 plus 5 times I2, and further it will be 6 3s are 18, minus 18 minus 30. It will be turn out to be minus 48 is equal to 0. We will better write it on that side for our calculation purpose. Okay, so let us assume this as our equation 1. This is my equation number 1. I will just recheck my calculation. This will be 5 minus 5 into 6, it will be minus 30, and minus 3 into 6, it will be minus 18, and when we sum up both, it will be minus 48, and the minus 48 will go on that side to become plus 48. Okay, so it is correct. Now KVL in mesh 2. Again through 5 ohm, my 6 amps as well as I1 is flowing, but now here my core direction is this one, that is clockwise, and for 5 ohm these are terms to be opposite. Okay, so I will just write the equation minus 5, always minus sign outside, and this will be I2 minus I1 minus 6. Now in through current through 6 ohm will be minus 6 times I2, and through 10 ohm will be minus 10 times I2 minus I3, and through 10 volts, this is in direction with the core direction, so it will be plus 10, and through 2 ohm it will be minus 2 times I2, which is 0. Okay, so I'm solving the entire equation. On simplifying this equation, we will get 5 times I1 minus 6, 10, 16, 17, 18, 18, 19, 20, 21, 22, 23. It's minus 23 I2 plus 10 I3. Next I will just calculate it. Okay, it's plus 10, it's minus 30 plus 10 minus 20. Okay, minus 20 will go on that side and do plus 20. Okay, this is my equation number 2. I will just name it equation number 2. Now I will apply KVL in mesh 3. So in mesh 3 we have again core direction to be clockwise. So I will just write its equation. Now here you can observe that 12 volt is against the core direction, so it will have a negative side. So minus 12 minus 6 times I3 minus 10 times I3 minus I2 minus 4 times I3 minus 3 times I3 is equal to 0. Okay, so on simplifying this equation, we will get the following result as 10 times I2. Now 10 plus 6, 16 plus 4, 20 plus 3, 23 minus 23 times I3 is equal to 12. Okay, so I can also write 0 times I1 plus. This I have meant for simplification, while we will use calculator, the scientific calculator. And here also I can write plus 0 times I3. It won't matter, as we are considering I1, I2 and I3 as our 3 unknown variables. And now we will input all these values in scientific calculator, and I will just write answer at the bottom. Okay, so I just calculated the values on my scientific calc. So I1 turns out to be minus 8.2 amps. Now why minus sign? Because the current is flowing in anti-clockwise direction. Okay, now I2 is also minus 3.5 amps, so it will be 3.5 amps flowing in anti-clockwise direction. And I3 is also minus, so my I3 is minus 2.0. Okay, I will just write it 2 amps. It is 2 amps flowing in anti-clockwise direction. Okay, so now what was my question? Okay, question was through current through 4 ohm. So I will write here I through 4 ohm is equal to 4 ohm is here and I3 is flowing through 4 ohm. I3, which is equals to 2 amps flowing in anti-clockwise direction. Okay, this is my final answer. Okay, so thank you. Now I will end up my lecture here, and in next lecture we will discuss about nodal analysis. So practice more. Thank you.